This is section 7.5, and this is video part 1 for systems of inequalities. Today we're focusing on objective 1, and it's actually objective 2 as well, and we're just going to be graphing inequalities today. Now, the steps that you're going to follow would first be to change the less than or greater than sign to an equal sign and graph. Now remember, before you even do that, you're probably going to want your equation in y equals form unless it's a circle. So then, when you're graphing, if it's a less than or a greater than, you're going to graph with a dashed line, because we can't include the points on the line. If it's an equal to, then you're going to graph with a solid line. When you're done with that, you're going to test a point. If your point works, meaning you get a true answer, then you're going to shape where the point is. If the point doesn't work, you'll shape the other side. And we'll take a look at an example right away. We're going to graph y is greater than negative 2x plus 3. So the first thing we're going to do is just graph the line, just the way it would be. Negative 2x plus 3. So we'll go to 3 on the y-intercept, and then use a negative 2 slope, so down 2 over 1. Now, because it's a greater than, not an equal to, we're going to graph with a dashed line. Now, what we're trying to represent with the graph is all the points, x and y, where the y is bigger than the negative 2x plus 3. We're going to get a lot of solutions here that work, so we're going to see where they're located. I'm going to pick a point to test. Now, because 0, 0 isn't on my line, I'm going to choose that. 0, 0 is going to be a great point to use unless your line or your equation, your graph, goes through 0, 0. Then you have to pick a different one. I'm going to plug it into my original inequality, so I'm going to get 0 is greater than negative 2 times 0 plus 3. And if I do a little simplifying, I get 0 is greater than 3. Now this is a true answer. This is true. 0 is in fact greater than 3. So that tells me I'm going to shade the side of the line that includes 0, 0. And the shaded region here would represent all the points that work in this inequality. Let's look at the next example. Again, we're going to graph the line as if it were equals. So we'll go to negative 4 on the y-intercept, and our slope is 3, so up 3 over 1. And now it's a greater than or equal to, so that means we get a solid line. The second step will be to test a point. Let's test 0, 0 because it's not on my line. I get 0 is less than or equal to 3 times 0 minus 4. 0 less than or equal to negative 4. Now, negative 4 is not bigger than 0. We get a false answer here. That's not true. So that means I can't color where 0, 0 is. Instead, I have to color the other side. And the shaded part represents all the solutions, including the points on the line. This time we can include the points on that line because it's an equal to. Let's look at another example. X is less than or equal to negative 2. Now, the first thing we need to think about is the line x equals negative 2. That's going to be a vertical line at negative 2. And it's going to be solid because of our equal to sign. Now, you can test a point just like we've been doing. Let's just test 0, 0. Now I'm going to get 0 less than or equal to negative 2. And this is false. So we're going to shade the other way. Now, another way to think of this one without testing a point is that this is x has to be less than or equal to negative 2. And you can notice that we shaded all the x's less than or equal to -2. So we could figure out that shading without actually testing the point. Here's a y equals. Remember, a y equals line is a horizontal line, so we'll draw a horizontal line at 1. And actually, this one should be dashed because of the greater than sign. And we want to shade all the y's that are greater than 1. So we're going to shade all the y's greater than 1. Now, if you wanted to test a point, 0, 0, you'd get 0 is greater than 1, which is false, so we shade the other side. All right, now that we've showed examples of lines, we're just going to do a couple more examples. And these are going to include equations that aren't lines now, so nonlinear functions we're going to graph. Here's the first one, x squared plus y squared is greater than 16. Now, if I think of this as an equals, this is going to be a circle. The radius is at 0, 0. And, I'm sorry, not the radius. The center is at 0, 0. And the radius is going to be 4. So we have to remember our circle properties. So from 0, 0, here's my center. Now remember, this isn't actually a point on the circle, but we're going to go out 4 in all directions from there. So I'm going to erase the 0, 0 because I don't want to get confused. It's not actually on my circle. And I have a greater than sign, so that means that my line should be dashed, my circle. Now, just like before, we're going to test a point. I'm going to use 0, 0. Remember, it's okay because it's the center. It's not on the circle. I'm going to get 0 squared plus 0 squared is greater than 16. And this is a false answer. So that means I'm going to shade outside the circle. And notice now that I'm going to shade all around here. So everything but the points inside that circle are going to work. Think of your equation, your graph, as kind of the boundary. Let's look at one last graph. Y is less than negative x squared plus 4. Now if I change it to an equal sign, this is in fact a parabola. Now the negative, remember, is going to make the parabola open down, and the plus 4 is going to shift the parabola up 4 units. So I'm going to go to positive 4. And put a dot. I'm going to go over 1 and down 1 and over 2 and down 4 in both directions. And my parabola is going to open downwards, and it's going to be a dashed line. The next step is all the rest will be to test a point. Let's test 0, 0. So I get 0 is less than negative 0 squared plus 4. 0 is less than 4. And this is a true answer, so we're going to shade inside that parabola. And if it kept going downwards further, we keep shading more inside. So this is where we're going to end the lesson for today. In tomorrow's video, we're going to start to solve systems of 2 equations. So we're going to be graphing 2 of these at the same time and seeing where they're the same.